Hey everybody, Mr. Gill here, coming to you, rocking my Giants gear along with Eli Manning and Saquon Barkley in honor of the NFL draft, which is today or yesterday if you're watching this on Friday. Quick little health update. I am still feeling a little bit better, but I'm still getting pretty worn out, have very low energy, but overall, definitely feeling better, which is a good sign. So, hopefully, by this time next week, I'll be good as new. Today we're going to finish up Unit 6, last thing with Path of the Sun and all that before we move on to a brand new unit. First, I'm going to go over the key points from Tuesday because some of that was a little open-ended and confusing, and then I'll tell you about the final assessment for Path of the Sun. All right, let's get started. Okay, so first I'm going to go over this last two on part 2 of Tuesday. So that's where I saw some people getting confused, where we were looking at the equator on the summer and autumn solstice and equinox. So if we go to the simulation and see I already have it set on the equator for the summer solstice. And the interesting thing we see here is that even though we're at the equator where we expect it to be really hot, and even though the season is summer, we have only a 66-degree angle of insolation. And looking at the simulation for the equator, that's actually kind of low. It can get way higher over here. However, when we change our date to the autumn equinox, we'll see that that angle of insolation got way higher, almost 90 degrees. Same thing if we change it to the spring equinox. It is also almost 90 degrees, 85 degrees. So basically, with the equator, the highest angle of insolation, the hottest times, are actually fall and spring, not summer, which some of us might have expected. And then going to the next part, where you wanted to find a 90-degree angle of insolation on the summer solstice and the winter solstice. So what you do for that is first you set your date. So we're going to change it to the summer solstice, where again the equator has a shorter day. And all we're going to do is we're going to change our latitude. And if we increase our latitude, we see we're getting higher angles of insolation until we get to right around there. That looks around our highest of 87 that we were getting, and we see our latitude is 24 degrees north. So for this one, where it was the 90 degrees at noon, the best answer you probably could have gotten was 24 degrees north for the summer solstice. But let's switch it. What do we think it's going to be for the winter solstice? So if we switch to the winter solstice, we see it went way down for that. But if we change our latitude, so now we're going more south, we'll see that right there, 24 degrees south is where we get that higher angle of insolation. So for the highest angle of insolation for summer is going to be 24 degrees north. Highest angle of insolation for winter, 24 degrees south. We're going to come back and talk about those dates later. All right, and then for these last two, I'm gonna answer that in this wrap-up PowerPoint. So first, we saw, and you saw this last time, that sometimes the sun will never rise and never set. That only happens at specific days, not all the time, only specific days. And that's only at the Arctic Circle near the North Pole and the Antarctic Circle near the South Pole. Those are the only spots where the sun can sometimes, not all the time, sometimes, never rise and set. Now, this is what I was just showing you with the 90-degree angle of insolation. That's these special areas we call the tropics. So 24 degrees, or more specifically, 23.5 north and 23.5 south, we call those the Tropic of Cancer and the Tropic of Capricorn. And any area in between those tropics, near the equator, those are the only spots you can get a 90-degree angle of insolation on specific days. Outside of that, it's impossible. Also, that number, 23.5 degrees, should sound familiar. Do you remember what else? Where else have we seen that measurement, 23.5 degrees? Yeah, that is also the measurement of the tilt of Earth's axis. That is not a coincidence that our tropics and the tilt of Earth's axis are the same measurement. All right, and then lastly, for longitude and latitude, you should have seen latitude changes the angle of insolation, longitude does not. When we change our latitude, the closer we are to the equator, the higher our angle of insolation is. And then the closer we get to the north or south pole, the lower our angle of insolation is. So right here at the equator, very high angle of insolation, lower the further we get. Longitude changes your time zone, changes your time, has no effect on the angle of insolation. To prove it, let's go back to our simulation. And we'll see right here. I'm going to change my longitude. And as I change my longitude, you can see in the map that I'm going all over the world. And you can see that the time zone is changing. That's why it's like a different time in California as it is here. But if you look at the angle of insolation, yeah, it might change it a tiny bit, but it doesn't really have an effect. The only reason it's changing the angle of insolation is because it's changing what time it is. So longitude doesn't do anything. Latitude has a big effect. So to sum it up, on specific days, sun can never rise or set, only in the Arctic and Antarctic. Sun can only have 90-degree angle of insolation between the tropics. Latitude will change your angle of insolation, longitude does not. All right, that wraps up Tuesday, so let's take a look at what we're doing now. Okay, so for the final assessment for this unit is inspired by something I loved when I was a kid called Where in the World is Carmen Sandiego? It was both a game and a cartoon that was on in the mornings. If you never heard of it, here's a little taste of the 90s-tastic theme song.
Tell me where in the world is
Carmen Sandiego.
So basically, here's the idea. Carmen Sandiego is an expert jewel thief who steals diamonds and hides them over the world. And it's your job as a detective to kind of follow the clues she leaves behind to find where the diamonds are. So in this case, you're going to be tracking down the locations of some diamonds using what we know about the path of the sun, the simulation, and a little bit of Google detective work. So like last time, you know everything you need to do it. So if you want to just jump right in and start the work on your own, you're free to end the video and do that. Or if you want to stick around, I'll kind of give you a few extra tips, walk you through a little bit of the first one, stick around. So your choice. What do you want to do? All right, so here is the assignment you have on Google Classroom. So you got a repeat of the background and directions that I just said earlier, and links to those resources that we've been using. So for clarification, the explanation, which is the last part, basically where you say how you found the spot, that is the most important part for your grade. If you just do a short, like few word explanation there, you're probably going to get a 1 or a 2. You got to explain the steps you used to find the location. Also, some parts of this are harder than others, and therefore they're only for level 4. So if you see anything that says level 4, you need it to earn a 4, but it's optional to earn a 3. So I recommend trying all of it, because if you basically leave the level 4 stuff blank and do okay on the rest, that's going to be a 2. But if you at least try the level 4 and it's not quite right, you can still get yourself a 3. All right, so the first one is kind of the easy one. So our clues are the diamonds are hidden in the United States, so that should help. The longitude of the diamonds is 84.39 degrees west. So anytime you have a location like that, I recommend go to the simulation, enter that. It's going to help. The diamonds were hidden on the summer solstice. So just like I said with the longitude, go to the simulation, enter the summer solstice. That'll help. Clue 4. On the day the diamonds were hidden, the the angle of insolation of the sun at noon was 78.6 degrees. Okay, so now that we know the date, we know that longitude doesn't really change our angle of insolation. What thing would we have to be changing on the simulation to try to find that angle of insolation of 78.6? Yeah, we should be changing our latitude. So once we have our date and longitude set, and we change our latitude, we should be able to get something that's pretty close to 78.6. And once you have that longitude and latitude, if you look those up in Google, you should be able to find what state that's in. And once you do that, once you have the state, you're just literally explaining how you found it. So what information did you use, and how did you use it to try to find the state? So for the level 4 stuff, the city and the exact building. So all the cities are big cities. So it's just like I said where you're finding the state, type the latitude you found and the longitude given, and if you look that up on a map, you should be able to find a city. And then for the exact building, we'll see clue 5. The diamonds were hidden in a building where a professional football team plays. So if you know what the city is, and you know you're looking for a stadium where a football team plays, if you look those up on Google, you should be able to find the exact building. Again, these are level 4, so if you're like really lost on that, don't worry about it. But those of you who are good Google detectives, I bet you can figure it out. And again, the next one is a little bit harder, and the last one is pretty challenging. So this whole last one, that's just optional if you want to go for level 4. Location 1 and 2, you definitely need to do, but location 3 is optional for level 4. And remember, if you're confused by any of this, email GChat, myself, or Mr. T, or you can also come to office hours later this afternoon. All right, good luck, everybody. See you later.